number 70, we're asked to solve this inequality. It's a quartic. We are allowed to use our calculator. So of course the first thing that we're going to do is put this in y equals and take a quick look. If we do that, we realize that we really can't get a very good view of this without changing our window. After searching around, we find a window with a minimum y value of negative 250 and a maximum y value of positive 200. And this seems to work very well to give us a picture that we can work with. We're also able to identify our zeros. According to our calculator, we have zeros at negative 4, negative 1, positive 3, and positive 7. Let's just put in a sketch. Looks something like this. Now remember, our inequality says we're looking for the parts of the equation that are greater than or equal to 0. This means we're interested in the parts that are on or above the x-axis, because that's where y is greater than or equal to 0. Shading those parts in, we see that we have the left end of the graph, and then we have the hump in the middle, as well as the right end of the graph. These are all above the x-axis. Because it says greater than or equal to, we can also include these closed points or the zeros on the x-axis. Now, in interval notation, let's write out the x values that produce these parts of the graph. If we want, we can shade them on the x-axis. Notice it's going to be all the x values to the left of our x-intercept negative 4. All of the x values between the two x-intercepts, negative 1 and positive 3, in addition to all of the x values to the right of our x-intercept, positive 7. Writing those out in interval notation, we get from negative infinity to negative 4, including the negative 4. We're going to combine that with all the points between negative 1 and 3, including those endpoints, and with the point 7 and all points greater than that all the way to infinity. The symbols in between the intervals are union, saying that we are combining all of these sets together.